Welcome to this course. This course is about mastering Kubernetes. So what are we going to do in this course? First, we are going to talk about what is Docker, why do we need Docker. Then we will talk about the different deployment strategy that we used to have in the past. Then we will talk about what is Kubernetes, architecture of Kubernetes, and after that we are going to look into the different components of Kubernetes like nodes, worker node, master node, pods, service, API server, controller manager, and much more. And then we will look into how they all work together to provide the functionality that a Kubernetes cluster should do. After that, we are going to generate a Spring Boot application and write a get endpoint. Then we'll go ahead and install the single pod MiniKube Kubernetes cluster on our laptop. Then we will go ahead and Dockerize our Spring Boot application, and then we will go ahead and create the deployments and the service objects for our Spring Boot containerized application so that it can be installed as a container inside a pod of Kubernetes cluster. We will be also looking into various debugging Kubernetes commands like getting the cluster information, checking the pods, checking the deployments, checking the service, deleting the service, and many more such commands like checking the logs inside the pod. We will be carrying out all this with hands-on examples so that we will not just learn but we will also practice everything about Kubernetes, which will make us much more comfortable in all the concepts related to Kubernetes while we are working with it. So if all this sounds interesting, then join me in the course. I will see you there. Thank you. Welcome back. Let's go ahead and do the environment setup for our development. So first thing, go to Google and type Java 8 download. Once you type this, you can go to this link where you will be shown a page for Java SE Development Kit 8. That's the version we will use. And then go to the bottom and download the Windows installer for you. If you are using any other operating system, you can go ahead and choose the corresponding package. So for Windows, go for this exe file. Once you have downloaded this exe, just double click on it and then go ahead with the installation process. After that, we will need an editor for writing the code. So we are going to use IntelliJ Community Edition, which is free of cost. So just type in Google IntelliJ Community Edition download and click on the first link. It's going to take you to this page. You can go ahead and download this community version and just click the installation click through the installation process and you will be able to set up IntelliJ. Then of course after the IntelliJ is open, it will automatically pick up the path for your Java 8 installation. Then we will need Maven for our build package management. So on Google type Maven download, click on this first link and then go to this files and then take this zip file. Download this zip file. You can keep it in your computer. Just extract it in a location and then go to your computer's environment path and give the path of the extracted home directory of this package. And then you can put a /bin. So give the path until bin in your path variable of your environment variable of the computer. So that will set up your Maven. So we have done setup of Java. Then we have set up Maven. We have set up IntelliJ. Next thing is go to the Spring Initializer. Click on this. And here you can choose Maven as a project and Java as the language. And then you can choose for the latest stable one. Now it is this. You can also go with the previous version. Give your group name, artifact name, package name. Choose from here jar and choose Java 8 And then you can add dependencies like Spring Web for building RESTful web services, and Spring Data JPA for database connectivity, and Lombok for quicker annotation for getter and setter methods. Once you have done that, just click on this generate. It will download the zip file for you. Extract the zip file, and then once you have installed IntelliJ, go to IntelliJ, click on File, Open Project, and browse to the location where you have extracted the Spring Initializer project. Then IntelliJ will automatically start to do the Maven build of your project. And finally, we have to download and install one another software, which is Postman. So this Postman will help us for testing our request and responses of our REST API. So you can go ahead and download this and install it in your computer. After that, you can open Postman and start generating request and response to your Spring Boot application. So this is the complete setup process. Thank you. I will see you in the next video. Let's look at how we can install Docker engine on our computer. So go to this website called hub.docker.com and sign up for an account with your email address. Once you have signed up and logged in, then you're going to see a screen like this. If you go to the home, on the home, you will see a download button for download for Windows. If you are using a Mac, click here, download for Mac or Linux. Once you have clicked on this button, you will get the exe file for Docker Desktop. Just run the exe as any software by clicking next, next, finish. After the installation is done, what you are going to see is on your desktop, you will see this icon, Docker Desktop icon. Just double click on that, or you will also see the Docker icon here in your toolkit. Once you have double clicked on the desktop icon, you will end up with this screen. Here you will see a sign in button. Now what you can do is you can log in with the same credentials that you have registered on hub.docker.com. After we have done this, then two things are achieved. Number one is we have made sure our computer understands Docker commands with this Docker Desktop engine. Next is we are already connected with the hub.docker.com repository. If we have done this, then we are good for the next steps. If at all you want to verify whether your Docker is running or not, so just type here any command prompt and just type here Docker. You should see this kind of output when you type this. Making sure by writing the Docker command, if you get this outcome like me, then you have successfully installed your Docker. What is Docker? Let's try to see the official definition about what is Docker. Docker is an open source platform for building, deploying, managing containerized application. We will come back to this definition, but let's go ahead and first understand how we do software development and deployment as of today, let's say without Docker. First, we will understand this process. Doesn't matter which technology you are doing deployment or development and deployment today, you will recognize these stages. Let's say you are using Java and Spring Boot to do some development and create some microservices. So definitely you need the source code. Then what you need is dependencies, and you need a build manager like Gradle or Maven. Then you need a runtime environment like JDK, OpenJDK or Java. After that, you do some configuration. You set your Java home or Java path so that your configurations are working. Similarly, for Maven, you do the setup for the M2 folder and path to your M2 folder and in your environment variables. Next is, once everything is done, you do a setup. Either you set up a Tomcat server or you try to use the embedded Tomcat server inside Spring Boot. If you take example of, let's say you are doing development using Node.js and Express, same goes here as well. Like you have your source code where you write the code. Then you have your package.json with your npm dependencies. For the runtime, you install Node from the Node.js org website. You install and download it, and then you install it, and then only your computer starts to recognize Node. And then you do some configuration here as well. You set the path and other stuff. After that, you install Express, and then with the help of Express, you create a server and you are able to build the application and see the changes on your local. Same goes for any other technology. Let's say PHP, Python, doesn't matter. There are certain steps and stages involved, which anyone or any developer has to do. After doing all this in your local computer, let's say if some other developer joins your team, he or she also has to do the same things to make sure the code runs on the local. Then, once the local development is done, you want to deploy the application onto the server. Let's say on your development environment, then on your test environment, acceptance environment, and then on production. So on those 4 environments also, these things has to be done. Like runtime has to be installed, configuration has to be done, server has to be made available, and then source code with proper dependencies embedded has to be pushed there. So you have to put 4 times the effort for your DTAP environment, like dev, test, acceptance, and production, to make your code run there. And then definitely you will come into a classic problem that, all right, my code is running in my local computer, but it is not running on the server. Maybe you missed some dependencies, or maybe you forgot to set the environment path. Something or the other, or you installed a wrong version of runtime. So something or the other definitely goes wrong. If you do or try to play around with these blocks yourself each and every time on different environments. So you definitely come into situations, if not you, your colleagues. I worked on it and it was working in my local computer, but it is not running there. Then you start investigation, find out, okay, this was missing. You fix it in one place, then you fix it in another place. So these kind of classic problem arises if we do the traditional way of software development and deployment. So these kind of issues was easily solved with the help of Docker, the containerization approach. That's what we call it. Let's try to go deeper into it. So if we now look into the definition of Docker, it says that it is an open source platform. You don't have to pay anything for building, deploying. So you do your development and also you deploy the application and then manage as well. Containerized application. What does it mean? Container. If you see the picture of Docker here itself, what do you see? These blocks, these small blocks, they are actually containers, small boxes. And each of the box is having something inside it. And that exact same copy is duplicated in all others, which means if you have to do anything, you do it in one place and the same gets replicated. So what does this small box has? This is actually one container, and one container will have all these things. Just compiled version of source code, like with your dependencies, it will have your runtime, it will have your configuration, it will have your server as well, which means you don't have to do the hassle of configuring all this again and again on different environments. And you also don't run into the inconsistency. It's running here, but not running there. So that's the power of Docker. It gives you that capability to bundle everything together and ship it in a place where it's going to run exactly the same place. And if you take that bundle and try to run it in any other computer, it's going to run exactly the same way as it was running in computer X or computer Y. That's the beauty of Docker. It makes everything platform neutral, and also it takes away the whole hassle of managing your software dependencies or again and again based on environment, managing your runtime based on environment, managing your configuration based on environment, managing your server based on environment. All those hassle is gone with Docker. Let's further dive into the details of it. How does Docker does all this super magic? First, let's look at the benefits that we get out of using Docker. So the first benefit that we get is consistency along with isolated environments. As mentioned, in all the places, your application will run exactly the same way. It will be consistent and each environment will be isolated from the other. Cost effectiveness and fast deployment. Of course, you don't waste time in fixing problems at multiple stages or levels. So definitely you save time, and it also saves cost for you. Hence the deployment becomes faster. Third benefit is ability to run anywhere. This means that it doesn't matter whether you are running your application on a Windows machine or on a Linux machine or on Mac OS or any other server, doesn't matter. Unless and until you have a Dockerized version of application and certain things running the Docker engine running on the machine, your application is going to produce the same result as it was producing anywhere else. So a Docker engine should be running based on the operating system, and then you just throw this bundle of your application, this one, with your dependencies and runtime, and Docker engine is going to take care how it will run it there. So ability to run anywhere. Next is uh, automation, test, rollback, deployment. All these things becomes quite faster. You can automate things now because you don't have to do any manual things again and again. You can test your application faster. If you needed, you will roll back and deploy a new version again. And the last one is modularity and scalability. Now your application becomes quite modular, which means if you have one bundle, let's say this one for Java with Spring Boot, another bundle with different runtime configuration and server and dependencies for Node.js and Express, maybe a third bundle for something else like a Python-based application stack. They are all three will run in different environments, and they are all modular, and they know how to run their specific source code. Python knows how to run Python-based bundle knows how to run the Python code. Java-based bundle knows how to run the Java code. So it's modular and of course scalable. Let's say you have one container now running with one Spring Boot application, as soon as a lot of requests starts to come, this container has the power to scale up, duplicate itself, and it can become multiple. And that's the benefit about scalability. It can scale itself, upscale and downscale based on the traffic that is coming for that application. So these were the benefits of Docker. Let's look at some of the terminology in Docker. So first thing is on the left side, you have your application code, classic application code. It can be written in Java, Python, Node.js, C Sharp, PHP, .NET, any other technology. Just you have to name it and it's supported. And then you have to write a file called Dockerfile, exactly with the same name on the same root level of your source code. In this Docker file, you write some instruction. You write some plain English text instruction, what has to be done, how the application code, how the configuration that is needed by the application code, how the runtime of the that's needed by the application code, all this how part and from where it can be fetched. You write those instructions in this file. All right. So now this is a file like your, let's say, .java file or .py file or .js file. It's just another file, Docker file. It cannot do a magic of its own. Then we convert this Docker file into a Docker image by running a command. Don't worry about the command. We will look at them in detail later. But with one command, we tell the Docker engine convert this whole application and the dependencies and the configuration and other stuff into an image. That's called a Docker image. And we create a specific version of this image, which means if there's another change to the application code or the Docker file, you run the same command again and a new version of the specific Docker image is created. All right, so let's say in our case, the application was Java Spring Boot with a Docker file in it. And then you ran a command, it created a Docker image for that Spring Boot application. If you modified the code, build the code again, run the Docker image command, Docker build image command, it will create a new version of the same Spring Boot application. And what does the Docker image has? It has the code, it will have the tools and utilities, it will have the configuration. So it has everything that it needs to live in an isolated environment. In an isolated environment, that's what we saw. So this Docker image has everything, but it's still not running. Like the code, it was still static, just file on the file system. This is not exactly on the file system, but somewhere inside Docker engine, it is just sitting there. It's not doing anything. So you can keep a copy of this in your local Docker engine, like, or you can also push it into Docker Hub registry. Like, let's say in case of Maven, you have a Maven central repository where different dependencies are available. You either do a, when you do a Maven clean install or build, the dependency get downloaded. Similarly, when you build your application, you create the dependency of your own application and push it there. Let's say in case of Node.js or Python, you also in the Node.js, you have the npm registry where you pull the dependencies, packages and dependencies, and also push your dependency later on, your application dependency. Same way, we also have a registry for Docker, pushing the Docker images. So it's called Docker Hub registry, where you can pull some images that you need and also push the images. So this is public, But there are also private repositories, like one in your local, but maybe with the cloud provider. In Azure, we have ACR. In AWS Cloud, we have ECR. So those kind of repositories are also there. Next is, now, what if we want to do something? We want to do something with this image, right? Otherwise, it's of no use. It's not running or it's not helping. As soon as we run this Docker image, with the command, it starts to create containers. And containers are the actual living being or living entities of this application. This application with this configuration and this tools and utilities, all this come into real life existence with the help of containers. So this container one will run the exact same copy of this Docker image specific version. Container two will also run the same. Container three will also run the same. There can be n number of containers. That's the power of scalability, modularity and scalability. So that's what is this image about. If you see, these are containers, small boxes that you see. They're just sitting on top of Docker engine. So Docker engine is running them on your host operating system. So if I install a Docker engine on my machine, I will download the Docker engine for Windows operating system, which will be able to run my Docker containers. If you have a Mac, you download the same thing and take my Docker image from, let's say, Docker Hub, and you can run it there on your computer, and it will that image will know how to set up the code with configurations and utilities. So that's the power of run anywhere here. So Docker containers are the real world living entities. They occupy memory and space. Docker image is the bundled version of, let's say, your source code with utilities configuration and other stuff. Docker file is the script that you write, the instruction that you write about what all things should be part of the image, or maybe in exact terms, what exactly things are needed for running your containers in when the containers will come to alive. What are the all the other things that's needed? You write those instructions here. So this was all about terminology and different components of Docker, Dockerfile, Docker image, Docker containers. Of course, there can be multiple containers running. So let's say there's a container running for your application code, like SpringBoot, but there's also a Docker image which has produced a Docker container for the database. Now your application needs to talk to the database. That's why it's mentioned here, containers are isolated from one another, but they can also communicate between each other with the well-defined channels. Like here, when we do software development, we also connect to databases, and databases are running separately. Similar way, we can run database as well, but in another container, in another database will have its own image, Docker image, and it will run in another Docker container. So the application Docker container can talk to the database Docker container in real time via proper channels. So this was about details of various terms in Docker. Welcome. Let's talk about what is Kubernetes or K8s. We will go and talk about this. Before that, we need to understand something. We need to understand how the application deployment history worked out so far. How were we deploying applications and their infrastructure setup and the life cycle. Once we understood those things, then answering this question, what is Kubernetes, will be really easy. So let's go ahead and do that. So let's go ahead and look at the application deployment history. So if we talk about the traditional application deployment approach. It used to be that we used to get big racks of hardware. On top of it, we were having operating system installed, Linux or any other operating system, sometimes Windows. And on top of this, we were installing our softwares or applications. Of course, this worked out well, but it led to a problem: insufficient or inefficient utilization of resources. So these resources that we had on our hardware like RAM and other stuffs and the CPU, those were not utilized optimally. So sometimes this utilization went up, sometimes went down. So let's say this application was consuming too much of CPU and memory, so it was getting shortage for this application or maybe this one. So this was inefficient way of sharing this whole resources that was available. So that was the disadvantage of traditional application deployment. Then we move to virtualization and virtualization deployment mode. What changed here is we had hardware, on top of it we installed operating system. But then on top of it, this was called as the host operating system, and on top of it we installed a software called hypervisor. And then we started creating virtual machines. They were not physical hardware machine, but they were just virtual machines which we created out of this big machine. And then this virtual machine was having its own operating system and libraries. And then what we were doing is we were installing our applications on this virtual machine. Similarly for others as well. So this was more the virtualized deployment. This virtualized deployment was better approach than the traditional deployment because the utilization of resources improved drastically. So here what we found is the utilization of the actual physical operating systems and CPU and memory, they were improved, but it was still not good. The reason is this particular virtual machine was having its own operating system, and this operating system was also consuming resources. So that was not good in this approach. Hence, we had to find something new, which would have been much more efficient. So that one we will talk about in our next video. Thank you. So far, we know that the virtualized deployment model was better than the traditional model because it was saving some resources on our CPU and processing power and also on the memory. But then this was not the ideal approach. So we had to find something new. And that's where we moved to the container mode of deployment. And what does this mean is we have the host application or the host hardware, host computer. So this is a big host computer that you see in the blue one. On that we had hardware. It was having its host operating system, and then we installed something called as container runtime. And here when I mean by container runtime, I'm talking about Docker. So Docker is something we installed. So we can download Docker from the for the Windows and Linux environment and install that Docker runtime on our computer. So we started installing that Docker runtime on our hardware. What this enables is once we install the Docker engine on our hardware, then it allows us to deploy application into small blocks called containers. So if you see these are small blocks called containers, and then this container will be like acting as a self-isolated capsule or a group which will have everything that is needed for it to self-sustain independently wherever we throw it. So if we throw it into a Windows-based operating system, doesn't matter. If we throw it into a Linux-based operating system, it doesn't matter. This container is going to run as an isolated package independently because it has everything that it needs to survive. It has its application, it has its libraries, it has the file system of its own, it has its CPU, it has its own memory processing space. So everything is available inside this container. Hence, the container doesn't need to worry what operating system or host it is running on. Similarly, we can have many containers deployed inside a one particular big host where a container runtime is running. But then these containers are not just your application straightforward. They are something called as Docker images running, and then running instance of those Docker images are called containers. So what we you do is traditionally we create our application. So let's say this is our application, and this can be written in any technology, let's say Java, Java Spring Boot, or Node.js, Python, or PHP, doesn't matter. So usually we were deploying this application directly onto servers. But now with the container mode, we don't do that. We convert this application into an image which we call as a Docker image. How do we do that? We with the help of some commands that we write in a Docker file. So we create a Docker file. Here we write some commands, and these commands knows how to convert this image in this particular application into a Docker image. Then we have a Docker image. And now this Docker image is getting pushed to a repository where it gets stored. And now a Docker runtime, which we have installed on the server, knows how to fetch this image from this repository, and then with the help of this image it can run containers. So it can run container 1, container 2 of the same application. It can run multiple instances of container of the same application using the same image. But this can also run containers of application 2. Let's say there's another application 2 which has its own Docker image. This Docker image if can be also run here. So this can be, let's say, container 3. So container 3 is for this application. Container 1 and container 2 are for this application. So Docker runtime knows if we give it the Docker image, it knows to convert them into a running instance which we are calling as container. So if we go back to our example, here we see there's one application and there are two applications running inside one container. And this container it has everything that this application needs for them to run. Similarly, there are other containers which run. And this Docker runtime is doing the magic of making sure these containers are running smoothly independent of the operating system on which the host is running on. So they don't have to worry about it. So what I mean by that is if I take this Docker image and deploy it into a Windows based operating system, I don't have to touch this application, neither I have to touch the Docker file. This is going to run exactly same if it was to supposed to run on a Linux based operating system or where the Docker runtime is running. So this Docker runtime or this container runtime is making this Docker container run independent of the host operating system. So with this approach, what happened is it became very lightweight and cost effective, and it also can be now scaled up and down very easily, and the overall utilization of resources like CPU and memory reduced drastically because every container had its own share of the CPU and memory and file system. So the burden on the host operating system reduced drastically, and then if we had to run the same container in, we have to duplicate this 10,000 times. It was very easy to do that. And then if we have to reduce it to back to 10 container instances, we can also do that. So scaling up and scaling down also became very simple. So as a container has little bit of everything, so they can easily be deployed on any hardware and managed easily because they are decoupled from the underlying hardware. Hence, the container can be easily deployed on the local environment, on an on-premise infrastructure, on any other cloud environment like Google, Amazon, or Azure Cloud. The container doesn't have to worry about where it is going to get deployed. So that was the decoupling that happened and the efficient memory utilization happened with the introduction of container-based deployment. But then it also brought another problem. The problem was at any point of time there can be hundreds and thousands of containers running. There can be same application container running. Let's say container 1, container 2, there are two instances running. Container 2, there is two instances. Container 3, only one instance is running. Similarly, consider each container having a one application. Let's say it is having Node.js application, this is having Spring Boot application, this is having Python application, and doing different functionalities. Maybe this can also have a database running inside it as a container. So anything can run inside a container. So, but then these containers, they are running, and let's say there is a lot of traffic coming on. So container one instance needs to be scaled up to hundreds of container one. Similarly, when the traffic is gone, this should be reduced down to one container. What if the container one instance dies? Somebody has to come and bring this up again. Otherwise, the request to this container one will start failing. So this kind of complexity came up with this container-based deployment approach. So there was also a problem of monitoring the health of each containers, the security of these containers, how will these containers talk to each other. So those kind of things came into picture with this new container deployment approach. So how did this problem was, I mean, how does the problem got solved automatically? So for answering that question, we have to go to the next lecture where we will see how this problem was solved very easily. Thank you. Welcome back. So now we have the problem of container management. It becomes a bit chaotic if there are thousands of containers running together. How to manage them properly? And how to make sure we monitor them properly? How to make sure if a container dies, or to spin up another one for that? How to make sure there is auto scaling or the container numbers are increasing when the traffic is going higher and the container numbers are reducing when the traffic load is gone. Also, how do we make sure we do a deployment of a new version of this container application without impacting others? So all these questions got answered with the help of Kubernetes. So this is Kubernetes for you. It is the container orchestration tool. What it does is it does the management of containers along the lines of scaling down, scaling up, making them highly available, making them secure, monitoring of the containers, security of those containers. All these things is done by Kubernetes. So what is Kubernetes? Kubernetes is a container orchestration tool. It is developed by Google and then it was made open source. Kubernetes, also called as K8s, because there are 8 alphabet between K and S. That's why it's called K8s. So Kubernetes helps to manage containerized application where there are hundreds and thousands of containers. We already discussed this. Kubernetes provides high availability and high scalability in production environment. So if you want Kubernetes to add more containers for a particular application because the traffic or the load is going to increase. Maybe it's a New Year evening or a Christmas time. You have lots of requests coming for, let's say, payments. Then you can decide or configure Kubernetes so that it is going to scale up the number of containers for the payment application only. And once the job is done, it is going to scale it down. So if a container is not running, not available, then Kubernetes is going to create a new instance of it and place it for high availability. And application auto scaling, upscaling, and downscaling can be also easily handled with Kubernetes based on the traffic. So monitoring aspect, security aspect, everything is getting taken care by Kubernetes. So What is Kubernetes? It is just a container orchestration tool or container management tool, container lifecycle management tool. That's it. So now we are going to look into the architecture of Kubernetes. So let's do that in the next video. Thank you. Welcome. Now that we know what exactly is Kubernetes and what is its role, so now we can talk about the architecture of Kubernetes. So here is the architecture of Kubernetes where we see some kind of master slave or master node or worker node kind of architecture. But we see certain words node. What do they mean by that? So let's try to understand that. So Kubernetes works as a cluster. If I have a computer like this is just a physical computer. Similarly, I have another computer. We know that we can connect all this computer and form a network. So this is third computer and there can be more of such computers. Let's say this. So a Kubernetes cluster can be formed by connecting all this computer together. We can connect all this computer together and then we can form a Kubernetes cluster. So now this network of these physical computers, this can be either physical computers or virtual machines. Virtual machines. And virtual machines, as we know, they are simply like this. They have operating system and then on top of it there is this hypervisor and then virtual machines. So using a group of virtual machines doesn't matter if it is running, these machines are running on your on-premise infrastructure or they are running on Azure Cloud, Google Cloud or Amazon Web Services Cloud. So there's virtual machine 1, virtual machine 2. These virtual machines, they can be combined together and then we can install Kubernetes here and then Kubernetes cluster can be formed. So Kubernetes cluster. So what is this? We call it as Kubernetes cluster. That's what we are seeing in front of us. This is now a cluster or Kubernetes cluster. And in Kubernetes cluster, each of this machine is a node. This is a node. Each of the virtual machine or physical machine which is participating in the Kubernetes cluster is called as node. So some of the nodes will be acting as worker node who will just take instruction from master and work accordingly. Let's say this is also worker node. This is also a worker node. Majority of them will be worker node and there can be one or more than one master node. So this is going to act as a master node. Let's call it that way. So now we know that master can give commands to the worker and the worker can work on those commands. That's how it works, right? In the real life also, master gives commands and servant work on those commands. So now we know a Kubernetes cluster can be created around a group of virtual machines which are interconnected and each of the virtual machine in that participating in that cluster is called a node. There can be two types of node, worker node and master node. Master node gives instruction to worker node to what they have to do. Alright, with this knowledge, let's go and try to understand the Kubernetes architecture in the next video. Thank you. Welcome back. Let's dive into the architecture of Kubernetes. So now we know that node is a physical server or a virtual machine which is one of the participants in the Kubernetes cluster. So as per this picture, this is a node, this is a node, this is a node, but then this is a master node, others are worker node, and these nodes can be either physical machine or they can be virtual machines. Let's go ahead and discuss another topic which is called namespaces. So what is namespaces in Kubernetes? Namespaces provides a mechanism for isolating group of resources within a single cluster. What it means is that if we have a group of resources and we want to keep them independent or separate from other group of resources, we put them under one namespace. It's more like in Java programming language or any other programming language, we have a concept of packages in Java. So you are packaging certain things and putting into one package. That package is separate from the other package. So that's what it means. So namespaces provides a mechanism for isolating group of resources within a single cluster. So in this cluster, let's say I have certain items which I can group together and I want them to be isolated. I will call this as namespace 1. Similarly, some other items which I want to group it together and keep it isolated from this namespace, then I will call this as namespace 2. So this kind of namespace strategy is applied when you are deploying multiple applications on the same cluster, but still you want to have certain segregation in terms of security or in terms of isolation. So we can take the namespace help to achieve that kind of segregation. So namespace of resources needs to be unique, of course, within a namespace, but not across namespace. So what it means is if you have resources inside a namespace, then let's say resource 1 should have a different name than resource 2. But if that's the case within one namespace. So if I create here a namespace here, this is a namespace 1, and here I have resource 1, then resource 1 should have a different name than resource 2. But if I have another namespace here, namespace 2, here I can still have resource 2. Doesn't matter. This resource 2 is different because it's in this namespace and this resource 2 is different. So that's what it meant. Alright, now we know what is the concept of namespace. Let's look at our architecture. So here we just saw some uh, nodes. So here is a node, here is a node, here is a node, here is a node. Well, so a node, as we know, is just a physical machine or a virtual machine. And this is a master node and this is a worker node. So there are two types of nodes. And then each node each type of node, let's say the master node or the worker node, they have certain components which help them do their day-to-day job. Let's say on the master node we have these things called API server, controller manager, scheduler, etcd, key value store. We are going to talk about them, what they mean. Similarly, on the worker node we have certain components like the pods, kubelets, and of course the containers. So what do they do? So we need to understand this first. So let's go ahead and in the next video try to understand the components around the worker node. Thank you. Welcome back. Let's go through the key points. So we have discussed master and worker node together make a Kubernetes cluster. That's what we see. So this whole thing is called a Kubernetes cluster. And what do we see? A master node. There can be more than one master node as well if you need more high reliability or high availability. So, but the number of worker nodes are always more than the number of master nodes. That's for sure. So then we have something called as worker node and we have an Kubernetes internal virtual network. So master plus worker node together make cluster. That's true. Application as a Docker container gets deployed only to worker node. What do this line mean? So this, whatever we talked about so far, that application getting Dockerized into Docker image and then Docker image getting pulled and run as Docker container. This Docker containers only run in worker node. We don't deploy a Docker image of our application in master node. The Docker image or the container of our application only runs in the worker node. And then each worker node has a kubelet. So if we see, one of the component of worker node is called kubelet. So what does this kubelet do? So kubelet is just another software or is an agent that runs on each of the node in the cluster. So here it's running, here it's running, here it's running. So this kubelet communicates with master, and if something is changed in the master, then it's kubelet's responsibility to do that change on the worker nodes. What does it mean? So first, every worker node will have a kubelet agent running. That's what we see. Then, what is the role of this kubelet agent? It is going to take command from master. If some things has to be executed on the worker node, then the kubelet is going to take that command and go. It's this kubelet agent is going to run that command on that particular worker node. So it's like a service delivery guy who is taking instructions and executing it on the worker node if there is any instruction for it from the master. So now we know that kubelet is listening to the commands from the master and running it on behalf on a particular worker node. So let's see what is pod. Pod is basically a smallest unit of deployable component in Kubernetes. So if you see, every worker node can have more than one pod running. So there can be pod 1, pod 2, pod 3. Many pods can be running. And in each pod we can have the containers which will be running inside them. And what are these containers? These are the application which are dockerized, and from the Docker image, a container instance is created. So these containers are actually running inside this particular pod. So inside a pod also we can run multiple containers, but we are going to look at it later. What are the advantages and disadvantages of doing that? But at least inside the pod, we should run one container. It can be a database, it can be an application with Python, PHP, .NET, doesn't matter. So, and similarly, there can be many pods running on a particular worker node. So there are many worker nodes. Each worker nodes run many pods, and each pod can run containers. Hence, pod is called as the smallest unit of deployable components in Kubernetes because we don't deploy containers to Kubernetes cluster. Rather, we deploy the pods to the Kubernetes cluster. And whatever is inside that pod is going to get executed or keep running on the worker node. So this is about whatever we talked about the worker node and pods and kubelets. So in the next video, we are going to talk about the different components around the master node. So let's go ahead and do that in the next video. Thank you. Welcome. Let's go ahead and talk about the different components that we see around master node, which helps the master node for its day-to-day activities. So if we talk about that, the first component that we see is API server. So what does it do? So as we know that any instruction or any code deployment that happens on the goes is going to go inside the pod inside a worker node. So we need to provide the worker node instructions. How do we do that? Those instructions we provide via the master node. And how do we provide any instruction to the master node? We provide those instructions with the help of API server. So API server is a component. API server acts as a front end for the Kubernetes control plane where when we want to interact with Kubernetes cluster, API server helps to do that. So what does it mean? So basically, this whole master node is surrounded by something called as Kubernetes control plane. Why do we say control plane? Because the whole cluster can be controlled via this control plane. And on top of this control plane, there is something called API server. And API server is actually taking instructions from us, from the outside world, from here, from the developer, and then giving it to the master node, and then master node is sending it to the kubelets of the worker nodes, and then the instruction gets processed. But the API server, how do we access the API server from outside world as a developer? For that also we have three ways. The first way is a UI, which we say as a control plane. Second is APIs itself. So there are REST APIs which you can consume and build your own nice dashboard from where you can manage the master node. And there is another way which is called as the CLI tools. So we are going to look into the way how we will control our master node with let's say the CLI tool in future. So for now, just understand API server is the way to enter or give any commands to our Kubernetes cluster, and API server can be accessed in one of the three ways. One is the control plane, which is the UI API, and then the CLI tool. So in the next video, we are going to talk about the next component, which is the controller manager. Thank you. Welcome. Let's talk about the next component that is running on a master node. That's called controller manager. So let's look at the responsibility of a controller manager. So controller manager keeps track of what is happening inside the Kubernetes cluster. So a lot of things can be happening inside a Kubernetes cluster at any point of time. So somebody needs to make sure that it has an idea about what are the things that is going on. So controller manager is again divided into four types to take care of different types of things. So first one is the node controller manager. So what this does is it is responsible for noticing and responding when a node goes down. So let's say in my cluster this particular worker node goes down. So this the controller manager, the sub part of it which is called the node controller manager, is going to get notified automatically, and then it is going to act that in such a way that this node is going to it's going to come up again as soon as possible. So node controller manager is listening to the worker nodes about their health, if they are alive or dead. So that's what we now know about node controller, responsible for noticing and responding when a node goes down. Replication controller. This type of controller manager, which is replication controller manager, makes sure that the minimum number of defined pods or replicas are running in a cluster at any point in time. What does it mean? So there is a certain number of pods that should be always running in our cluster. So who is going to make sure that it is happening? So that is where the replication controller manager comes into picture, and it says, I will make sure that if you have said 10 pods should be always running, I will make sure 10 pods will be always running. Okay. Next we have the endpoint controller. So endpoint controller defines endpoints like how to connect to pods or services. So let's say we have deployed our container, packaged the container, uh, packaged our application into Docker image and then made it as a container, and then the container is running inside a pod. But there should be a way to reach to that container. Otherwise, it's useless application if I'm not able to communicate with it. Let's say this application wants to talk to this one, so there should be a way. So how can that be possible? That is possible with the help of endpoints. And who is making sure that the endpoints is made available? This endpoint controller, which is part of the controller manager, is going to make sure that it defines endpoints for the pods or services, and then using those endpoints, we can connect to that particular pod. Next controller type is service account and token controller. This is responsible for creating API token for a new namespace. Let's say a new namespace, and of course, namespace is nothing but an isolated group of components. So if a new namespace is created, so for that particular new namespace, whatever token that we need, API token we need, that is the responsibility of service account and token controller to create that token for that particular new namespace. So again, all these four controller types that we saw are actually bundled into same binary package, same jar package, and deployed inside our master node as a controller manager. And then out of this one binary package, all the four sub controllers are acting for different things that we talked about here, like the node controller, the application controller, endpoint controller, service account, and token controller. So this was about the other component, which is controller manager. So in the next video, we are going to talk about scheduler. Thank you. Welcome. Now it's time to talk about what does this scheduler do. So this scheduler component that you see on the master node is responsible for making sure that a pod gets placement. What does it mean? So let's say there are different pods. At any point of time, we know there can be multiple pods running on a worker node, and there can be similarly many worker node. So how do a new pod gets a placement in a particular node? So there has to be something done about that, right? So that's where the scheduler comes into picture. It manages the pod's placement, and if there is a new request to the API server for deploying a new pod onto this cluster, then scheduler is the component which does all the magic and finds a suitable node where this pod should be deployed and sends the command to that worker node. So what this means is that, let's say there is a new pod to be placed or deployed to one of these worker nodes. So the request from the developer via different commands, let's say via the control plane UI, or based on the CLI tool, or via the API, will reach that particular command will reach to the API server. And now API server is going to tell scheduler, hey scheduler, can you find a new place, a suitable place for this new pod in our cluster? So the scheduler is now going to come and check in these nodes which node is having the capacity to fit an extra pod. And once this scheduler finds that place, then what this scheduler will do is it will send that command to create a new pod to that particular worker node. Let's say this particular worker node has the capacity or it has the space to accommodate another pod. So what scheduler will do is it's going to send a command to the kubelet of this particular worker node to add extra pod, and then this worker node is going to execute the commands received from the scheduler to create an extra pod on its node. So this is how scheduler manages the pod's placement, and it does it with in coordination with API server and the kubelet of that corresponding worker node. So thank you. I will see you in the next video. So the next component that we want to talk about is etcd key value store. So what exactly is etcd key value store and what is its function on the master node? So let's go ahead and look at its functionality. So what this does is it is just a key value pair data store, but it is very highly available and consistent. And why it's the highly available and consistent? Because whatever is going on at a particular point of time in our Kubernetes cluster, the state of that particular the state of at any point of time, the state of the cluster is kept inside this key value pair HCD store. And how it does is it's basically going to store all the cluster data and everything that happens inside the Kubernetes cluster. It's going to store it in as a key value pair in this particular store, and it also gives the state of the particular of this cluster at any point of time. Hence it's very important that we maintain a backup or there is a duplicacy at this level. So in the production environment, we at least run two master node and several worker node, because the whole information about the state of the whole cluster, like this node, where are they, what are they doing, everything stored inside this particular key value store. So it becomes very important that should be a redundancy about this. Hence in production environment we run two master node in parallel so that the state is highly available and also consistent. So if let's say one master node goes down, then we have at least another master node running with a state of the cluster known inside the etcd key value store. So it's really very important data store which is uh, keeping the state of the cluster, and also it is making sure that if one of the cluster goes down, if the one of the master node goes down, the another master node can work with the worker nodes without any problem. So this is the functionality of HCD key value pair to keep a consistent and highly available cluster. Thank you. So last component in the Kubernetes cluster is this whole Kubernetes internal virtual network. So it is actually a network which is internal to the whole cluster, and this network actually facilitates communication between different components that we have talked about so far, and also it can facilitates communication between the master node and the different worker nodes. That's why it's very important that we know also about this, that Kubernetes internal virtual network facilitates all the communication between different components inside of our Kubernetes cluster. And without this network, the different components cannot interact with each other, and hence the cluster will be of no use. So this is the importance of Kubernetes internal virtual network. Thank you. Welcome. Let's talk about what is a pod. So as we know so far, pod is a smallest deployable unit. So if we look at one of the worker node, so worker node can have more than one pods. So every pod then contains the container with application and the library. So that's what we have discussed. So an application gets wrapped inside a Docker image, and then the Docker image is responsible for having the application and the dependent libraries together, and then the Docker image can be run, and then when a Docker image is running, it's called a container. So here, that's what we are saying. Inside a pod we can have one or more containers running. Similarly, there can be many pods running inside one worker node, and we see that there can be many worker nodes which are running different pods. So in short, pods is the smallest deployable unit. So let's go ahead and talk about some of the important key points around this. So best practice is to wrap one container to one pod. What does it mean is, even though we are allowed to keep more than one containers inside one pod, but we should not do that ideally. So I can keep an application and its database inside this pod, but then there can be a scenario that I need this application to auto scale and grow more, but I don't want the database to auto scale. So that's where the things become complicated. Hence, it is good and advisable that you keep only one container running inside one pod, and you can spin up many pods inside a worker node if you need. So that's why best practice is to wrap one container to one pod and deploy this pod as to an available worker node. Next is every pod when gets created, it gets an IP address, and if something goes wrong with the pod, it gets deleted and a new pod gets created with a new IP. So what does it mean? So basically what happens is, whenever we are creating a new pod, a new IP address is getting associated with it. And when the pod gets deleted, this IP address is also getting deleted. So using these IP addresses, different pods or the applications running inside different pods can talk to each other. But then there's a one small problem. Let's say a pod is with an IP of 1234, and then this pod is using that IP to connect to this pod. What happens if this pod gets deleted and then a new instance of the pod gets created, which means that this pod is going to get a different IP, which is going to be different than 1234. What it means for this pod then is that this connectivity is not no longer established. It is gone because the IP has changed. Hence, there's this to solve this problem of dynamic IP for a pod, we have got a new kind of technique called a service component. And this component comes into picture as it is an abstract way to expose the application container endpoints running inside the pod rather than exposing a dynamic IP. So it handles the complexity around creating a new dynamic IP. So what it means is that instead of these applications talking to each other with the help of IPs, rather they talk with DNS names which gets associated with every pod, and that DNS name is never going to change. Even though the pod is getting killed and a new pod is getting created with a new IP, the service is going to make sure the DNS name of this pod is never changed, which means this pod is going to talk to this pod via the help of this service, and which will provide a DNS name to this particular pod. So that's what it means. So service and pods have different life cycle. Whenever a pod is destroyed, the service remains intact, so we can connect to all the pods using service. So what it means is the life cycle of a pod is independent than the service, which means if the pod is getting destroyed, it does not mean that the service is getting destroyed. Service is still there and it is waiting for this pod to come up again with a new IP, which means this service is now, if we are calling this particular pod from this pod via the service, this service is actually responding. So service has static IP address attached to it, that is a DNS name, and it is a load balance system, which means we can create multiple pods and attach to a service, and we can call these pods exposed endpoints using this service from any other application in our microservice architecture. What it means is this service is an application which is load balance, which is acting in the load balance mode. What it means is as many as request comes to it, it is going to route that request to different pods, just that different pods have different DNS names. So we should make sure when we are calling pod 2 from pod 3, we should use proper DNS name which is provided by service. And if we call many lot of we make many calls, then the service knows how to pass traffic to pod 2 in a load balanced environment. So we don't have to worry about that. So again, service is just having a static IP, or that is acting as a DNS service, also as a load balancer to route traffic between the pods. So the service component helps to solve the dynamic IP address issue that we were getting when we were directly trying to access a pod from another pod with the help of IP address. So this was about a short deep dive at what is a pod and how what is a service and how different pods talk to each other inside worker nodes. Thank you. So let's talk about what is replica set. So replica set are another abstraction layer built on top of the pods. So replica sets guarantee that there will be a specific number of identical pods running at any given time. When using replica sets, you we can basically enforce a minimum number of pods that that should be running for our application. So replica sets are just an abstraction on top of the pods, and it is nothing but a guarantee that there will be a minimum number of pods always running. And of course, when we say minimum number of pods, we can configure that. What is the minimum number of pods that should be running for a particular application? So that's what is replica sets. And this replica sets work together with this controller that we discussed here. We discussed that replication controller make sure there's a minimum number of pods or replicas are working together or running together. So that is what is done with the help of replica sets. Thank you. Let's talk about what is a deployment. So all that we have discussed so far about Kubernetes and cluster and the master node, worker node, pods, service, all these configurations can be wrapped in something called as a deployment component. So deployment component is an abstraction over everything that we talked about. So if we have multiple applications, multiple databases, then we can wrap all this information into one single deployment and then do a deployment to our cluster. And this particular single deployment can be directly deployed to our cluster. So in this deployment, we can also define how many replicas we want to create and how many when do we want to do an auto scale and when do we want to do a downscale. All this configuration we can put in this single deployment. So how do we create this deployment? We have to basically create a YAML file or a JSON file, and we have to write all the commands that we want to go in this deployment. Let's say we have two application, two databases, conditions for auto scaling, down scaling, the replica sets. All this we will write in this YAML or the JSON file. Then what we will do? Then we have to feed this JSON file or the YAML file to the API server of the master node using either the UI or the API or CLI. So when I say CLI, we have a popular tool called kubectl that helps to run this YAML or the JSON file commands onto our API server of master node. Once we have done this, then what happens is this configuration or present in this YAML file or the JSON file is passed from the API server to the master node scheduler, and then it goes to the controller manager, and then the controller manager puts it to the final worker nodes, and then the kubelet running on the final worker node is going to execute this command on that worker node so that the effect is going to take place. So there are other tools also which makes life simple for different deployments and rollbacks and upgrades. One such tool is Helm Chart Manager. So Helm is a tool like we have different tools, let's say for installing different things. Let's say I want to install a new package on a Linux environment. So I have this apt command that I run. We have a pip for Python. So similarly, we have an installer or a package manager, or let's say the Helm package manager or Helm chart manager that takes care of these all these configurations that we will create for multiple deployments. And then if we want to do an upgrade to a deployment, if we want to remove a deployment, if we want to uh, know how many deployments are running at any point of time, so those things get simplified if we use tools like Helm Chart Manager. So this is what is about deployment and how deployments helps us to deploy instructions to the master node, and then it gets passed through to the worker node for the changes to take effect in. Thank you. Welcome. So far whatever we discussed about Kubernetes architecture or the Kubernetes cluster, like the master node, worker node setup, we can recreate this whole cluster on our local computer, whether Windows or Linux, with the help of a software that is called MiniKube. So it is going to run one master node and one worker node for us to try out different things. And we can use the CLI tools like kubectl to interact with our MiniKube created Kubernetes cluster. But on if you want to install the Kubernetes cluster on your on-premise infrastructure, then you have to make sure there are different virtual machines running, and you can download the Kubernetes uh, and then install it on that on-premise infrastructure. But if you go for, let's say, a cloud solutions like Google Cloud or Azure, Microsoft Azure Cloud or Amazon Web Services, then they provide you these services out of the box. So you get something called as AKS, Azure Kubernetes Service for Microsoft Cloud, which will give you this whole setup out of the box. You just have to press some buttons and you will have the worker nodes created, and the master node control plane will be ready for you to use. Similarly, in uh, the Amazon Web Service environment, it is called EKS, Elastic Kubernetes Service. And similarly, in Google, it's called GKS, which is Google Kubernetes Service. So all this does the same thing, that they create the infrastructure for you. They take care of all those hassle. You don't have to worry about creating infrastructure or the hardwares that's needed. You just have to pay for the number of worker nodes you use, the configuration of the worker nodes, and the master node configuration. You just have to pay as you go and pay as you use. So there, for starting purposes, you can install Minikube on your computer and get started and experimenting all the topics that we discussed, and try out some deployments and see how it works. But if you want to go for a more production-based approach, then you should go for either some of the cloud environments like Google, Azure, or Amazon. Thank you. Welcome back. Let's look at the different service types. We know that a service is a component that helps us to talk to the ports inside our worker node without we having to directly choose the IP of the pod and interact with it, because we know the IPs tend to change dynamically. But this service component is also of different types. So let's look at the different types of the service component. So the first type of the service component is cluster IP. What does it mean is it exposes a service which is only accessible within the cluster. So if we choose the service creation and service while creating a service, if we choose the type as cluster IP, then it is going to create a service which is only accessible or private to the Kubernetes cluster. But if we choose the service type as node port, then it will expose a service via static port on the node's IP address. So it will create a static port on this particular worker node IP address level, and we can then access the pod with that port and then the worker node IP address. Then the third type of the service type is load balancer. This is mostly used in the production environment where it exposes a service via cloud provider's load balancer. And this is also the most useful one on the cloud environment because this helps the service also act as a load balancer to route the traffic according to the load. Then we have the external name. This is a service type which maps the service to a predefined external name field by returning the value for a CNAME record. So if we want to map a domain name, let's say specifically for our need with the help of CNAME record, then we should go for this external name service type. So these are the different service types that we have in Kubernetes. Thank you. Welcome. Now let's go ahead and install MiniKube on our computer. So first thing first, let's quickly understand what is MiniKube. So far what we have learned is Kubernetes cluster is a combination of different nodes, they work together. And of course we can create Kubernetes cluster on cloud. But what if we want to run a single node Kubernetes cluster on our computer? So that we can build our application, test it in that single node, and we are confident enough that it is going to work elsewhere. So that's where Minikube comes into picture. Minikube provides us that small single node environment or a cluster where we can run our application in our own computer and test it out. So first we have to go to download Docker desktop. So go to Google and type download Docker desktop, and it will give you this link where you can click download Docker desktop. Once you have downloaded this Docker desktop, go ahead and install it by following the normal installation process of next finish. It's very simple, just go ahead and do that. After that, on the browser type Minikube and click on this first link. Go here and then you will see Windows. This is the architecture stable. Choose the exe and click on latest release. So it's going to download the installer exe for us. And then we need a command line tool to interact with this Minikube and created cluster. We need to interact with this cluster. So this command line tool, which is kubectl, helps us do that. So type kubectl download and then click on this link. Then go ahead and click on install kubectl for Windows. And after that, click here to download the latest version. So let it download. So once the download has been done, go ahead and keep these two in the same folder in your computer. And let's follow the next steps in the next video. Welcome back. So far what I have done is I have just copied the Minikube installer and the kubectl installer and kept it in a folder in my computer. So what I will do now is I will copy this path and go to environment variable and add it to the environment variable. So go to path, edit and add here as this path. Now what I have to do is just go ahead and double click on this. Let it install the normal, by following the normal process, it will try to install this thing. So let it do that. So click next and finish. Once this is done, also double click on kubectl once and it will tell you that this is a command line tool that we have to run. Okay, perfect. Now what we have to do is just open a command prompts anywhere cmd.exe, and if Minikube has been installed successfully, we should be able to get the version of Minikube. So Minikube version, hit enter, and it tells you this is the latest version of the Minikube that we are using. Perfect. Now, in order to run the Minikube or start the Minikube cluster, because this Minikube is going to create one Kubernetes cluster, what we have to do is we have to make sure the Docker desktop that we had installed, it should be running. So just search after installing Docker desktop, click on this and make sure you open this and it is running on your computer. So it takes some time. So for me, the Docker desktop is running. So now I will just minimize this. And now what I will do is I will just open the command prompt and here I am going to type minikube and then start hyphen driver, because in order to run minikube we need to provide driver. So driver can be either a virtual box or a hypervisor, or in simply if you want to not go with the hypervisor or the other approach, then you can go with directly with Docker, because we are running the Docker desktop. So type driver equal to Docker. That's it. And if we hit enter, it will basically now. So there was a typo, so don't make a typing mistake. So here I have to say Docker. Hit enter. So now the Minikube cluster is getting started on the on the Docker driver. If you are using hypervisor, you can do that. If you are using VirtualBox, you can also use that as a driver. But I have used the Docker as the driver. And now it's going to download the necessary things and it is going to do the setup for us. But make sure you have this one installed. Otherwise, and this is running, Docker desktop is running. Otherwise, it will create problem and you won't be able to get the results. So for now, I will close this because in the background it is running for me. So let this run. This downloadation process is going to take some time. Once it is done, we will continue further. Thank you. Welcome. Now let's check. So we had started the Minikube cluster and then you see it took some time, but it did created a container and then it created a cluster for us. So how do we know whether the cluster has been created successfully or not? First of all, we'll check the Minikube status, whether it's running or not. So type Minikube status and we see that Minikube status is running successfully and it is running a control plane, which is the main Minikube uh, host container or the plane from where we control everything in the cluster. Then we have the host running kubelet, which is running, which is nothing but this kubelet is running on the worker node, that the single node that we have. API server this is running, kubeconfig is also running. So everything is running. So let's go ahead and also open a notepad and where we can write down these commands. So we can say minikube version, we can say minikube status. Then we have some commands related to kubectl. So with the kubectl, now we can interact with the cluster, single node cluster, because now it created a single node cluster. So let's go ahead and check to find out the cluster information. So we'll say kubectl cluster hyphen info. So let's save this command. So with this, we will get the cluster information, because as we know, the kubectl, the so here we have the cluster which is running. So Kubernetes control plane is running in this you on this URL, and then the whole cluster is running here. So this confirms that our Minikube single worker node cluster started successfully. So let's write down this command. So let me copy it again. After that, if we want to, let's say, know what is the status of that particular single node, so let's go ahead and do that. So kubectl, and then we can say get node. So it's going to give the information about that single node that was running. So we see that the name of the node is minikube, and it is in the running ready state, and of course it has two roles. One is control plane, and it is also acting as a master node. So this is how we can get information regarding a particular node. So, so you are seeing that we are able to now interact with kubectl and our cluster. So hence kubectl is the CLI tool which helps us to interact with our Kubernetes cluster with some commands. So this is it for this video. I will see you in the next one. Thank you. Welcome. Now that we have installed our Minikube cluster successfully, and we also verified the cluster is running with one node, and that's what the Minikube documentation says, that it provides a single node cluster, Kubernetes cluster, that we can run on our local laptop. So now it's time for us to create a Spring Boot application and then Dockerize that application, and after that we will install it on our Minikube cluster. So first I will go here into Spring Initializer and then give just name com.mycompany. Let's say K8s app, K8s with Spring Boot. I will from the package name I will get rid of this. It will be a jar with Java 11. Add the dependency Spring Web, Lombok. Yes, that's it for now. We need this much and generate this. So now it has downloaded. I will go ahead and extract it in a location in my computer and import it into IntelliJ. I will see you in the next video. Thank you. Welcome. Now I have extracted my Spring Boot application after unzipping. So I'm going to copy the path and open IntelliJ and go to IntelliJ and open this project from here. Open, paste the path, and then I can open my project here. So it's going to open it in this window. It's going to take some time. It's going to download some Maven dependencies for the first time. So we are going to give it some time. Let's wait for it. So it's scanning the index. So it has done everything as we expected. So in the next video, what we will do is we will just create a simple endpoint here, hello world controller endpoint, so that we can later on deploy this to our Kubernetes cluster and we can test it out with this hello world endpoint. So thank you. I will see you in the next video. Welcome. Let's go ahead and create a package called controller. And in this controller, I'm going to just create a controller class called K8 as controller. So I need to refactor it. It's a small letter. We should always keep files with capital letter. And here I'm going to just annotate it with the rest controller, request mapping. If you want, we can keep it at the top. API slash v1, and I can say public string, say greet or some, let's say, greetings, return welcome to the world of Kubernetes, and that's what we will return. And we will just say get mapping, and we'll say greet. Now I will start the application. Right click on this and application. Let's test out this endpoint if everything is working as expected. So starting up. Starting up. So it says it has started. So let's go to localhost 8080 slash API slash v1 slash greet. So here I can say http:// localhost 8080 slash API slash v1 slash greet. Hit enter and we see that the message is coming from our controller now. Welcome to the world of Kubernetes. Perfect. So far so good. Let's continue in the next video. Thank you. Welcome back. Now it's time for us to go ahead and dockerize this Spring Boot application. So for that, at the root I will create a file called new file Dockerfile, and in this Dockerfile I'm going to go ahead and say take the base image from open JDK and use JDK 11, and we will expose the port 8080 to the outside world because our Spring Boot will run on port 8080 here. That's what we saw and we know. So we want to expose that port. So this is the port on which our Spring Boot will run. So we'll expose that port to the outside world, and what we will do is once the package is built, whatever jar is getting generated here, we want to write it over the. So I'm going to show you what I mean by that. Let's do a maven clean install. So maven clean and install. So whatever jar will be created, we want to copy that jar into the container from our local computer to the container. So that we do by saying add, and then the name is target here. So from the target folder, so target, from the target folder slash whatever will be the file name, we have to paste it here. So let's see what is the file name it creates. If this folder will be now deleted and a new folder will be created, and that folder will have the jar name. So here we have the jar name, which is this. So I'm going to right click and rename, copy the jar name, Control A, Control C, and then what I'm going to say from the target, this copy this jar to directly onto the Docker file system. And then we have to also start the application. So that's where I will say entry point. So entry point is the command using which we can start the application by saying java minus jar, and that's the command we have to give in the entry point. And here we will say slash this. So this is the jar it is going to start inside the container Docker image. Perfect. So we have also successfully converted or created a Docker file for our application. Let's continue in the next video. Welcome. Now it's time for us to allow Kubernetes to have access to the Docker images which we will build on our local computer. For that, we have to run a command called minikube docker-env. Hit enter. Once we have run this command, then we need to run the command which is given by us at the last. So copy it from here to this and run this command here. Make sure to do this all from the same terminal location. So I'm using this terminal from the root of the application, so I'm doing it here. Now, once we have done this, we need to do the next thing, that is run the docker build command for running or building the image for our application. So the build command that we will use is this: docker build -t and then the name of the image and the version of the image followed by a dot. So let's see what it means. So docker build with -t, which is target, and the name of the image and the version of the image with a dot. Dot specifies in this folder itself we have the Docker file. So now hit enter. So it's going to build the Docker image for us. So let it build the image. So it's going to take a little bit of time to build the Docker image. Once it has built the Docker image, then we will run a command to see if this particular image is accessible to Kubernetes cluster or not. So that we will specify by running a command called docker images ls. Then we will get to know. So let's wait for this Docker build to finish. So now the Docker build is almost done. Perfect. So now let's go ahead and run the command where we will see if our this Docker build image is available to Kubernetes or not. So type the command here, docker images, docker image ls. So as soon as we run this command, you see this. This is the different Docker, the Kubernetes images. Along with it, we also have our own image. So always remember to use the same terminal to first run this command, which is minikube docker environment, and then take the last one and run this command. After that, in the same terminal do docker build of your image, then verify whether your image is visible to the Docker to the Kubernetes cluster or not with the help of docker image ls. When you run this command and if you see your image also along with other images, then we are sure that our image is available for the Kubernetes to access it and deploy it in its cluster. So in the next video, we are going to do that. Thank you. Welcome. Now it's time for us to create a deployment and use that deployment to instruct Kubernetes to create a pod in which it should run our Docker image as a container. So deployments are special objects that we can create and provide to Kubernetes cluster and ask the Kubernetes cluster to do the operations for us based on the deployment object instruction. So the deployment object can be created with the help of a YAML file, or we can also provide the deployment object instruction via command line tool like kubectl. So now what we will do is we will use kubectl for creating our deployment command and asking our Kubernetes cluster to deploy this particular image inside a pod. So if we go back to the picture, so here is what will happen. The deployment object will come here and to the API server, and then API server is going to pass it through to one of the worker node. In Minikube we have only one node, so here, and then this worker node is going to create a pod for us, and then the pod is going to get the image that we will provide and run the container out of it here. We can then see the details about the pod logs, all those information. So let's go ahead and first create our deployment command. So here I go, and this is the deployment command which I have already prepared. Here I am going to say kubectl create deployment. I will give the name of the deployment as this, and I'm going to give the image as the image that we have built, which is already done in the previous step. And then I'm going to say run this in the port 8080 inside a pod. So I'm going to copy this, go here, paste it, hit enter. So it says deployment created. So now how do I know whether the deployment was created successfully? So I'm going to do this. Copy this command and I'm going to say kubectl get deployment. So it's going to get me the details of the deployment. So here I see that there's only one deployment which is running. So now I need to get the details about this particular deployment, all the details. So I have to use the describe command. So here I'm going to say kubectl describe deployment and give the name of the deployment. So here we have only one deployment, so you see one. If we had more than one deployments, then we will get the list here.